workpiece, or sorry, the 1000 degree Celsius electrode to have a coating on it, to fill the gap. So at a fraction of a second, if you are going to melt a 1000 degree Celsius electrode, we have to produce the heat up to 5000 degree Celsius, so that this 5000 degree Celsius heat will helps to melt this 1000 degree Celsius electrode. 1000 degree means the melting point of the 1000 degree Celsius electrode. So this 1000 degree Celsius electrode will what will do? It will melt for a fraction of a second. It will come as a liquid part. So then it will fill this area, fill this welding gap, and it will, after a few seconds, it gets solidifies. From this liquid it comes to again solid. So this complete welding process will be done. See, I will show you a video. See, in this process, okay. Right. See, this is a proper electrode where you have a flux coating. Right. I will show you a video. See, in this electrode, okay, you can see this is the outer coating, right? Okay. This is the outer coating, outer flux coating. Okay, this is the electrode. Okay, once we are going to supply heat, this electrode will get melted, and it will. Okay, this solid is converted into liquid, and it will be coated out. Instant process. It will be coating. Okay, it will do this coating. So once, see, it's a full solid, but upon heating it comes as a droplets. Okay, upon droplets, right? Okay, then it will goes on fill the area. Okay, once now it's going on. You can see it became a liquid for a fraction of a second, right? It's a solid. Upon heating a 1000 degree electrode, have a 5000 degree arc power. Upon heating it to a 1000 degree Celsius, what happens? This solid electrode is converted into liquid for a fraction of a second. Then it becomes solidified. Okay, right. So now this flux comes into the picture. This electrode has only one process, that it will supply the electricity. It is get heated. It is going to melt, and it is going to do the welding. The flux which is coated over this electrode has two processes. One process, that this flux will create a shielding atmosphere. Here you can see some designs, right? It's a shielding atmosphere. Like while we are wearing gloves, what happens? It acts as a shield for our hand, right? So like the same way, this flux will create a shielding atmosphere. This shielding atmosphere will not allow the outer atmospheric air to enter in this weld area, so that we will get a proper quality weld. That is the first one. Second one is that this flux will mix with this area, will mix with this weldment, and if you have any impurities, these impurities will go on it will float on this liquid area. The impurities which is prevail here will float on this weld area. So once the solidification happens, it will float on, right? So this liquid will become solid. Again it will be floating on the top area. Okay. After that, after this welding is happening, what we will do is, see, here you can see this is a slag removed area. Okay, I will say what is slag. This flux, the flux will help us to move the impurities to the top side. The impurities are nothing but the slag. Okay, you can keep it in mind that in any welding, in any process, in mechanical, any process, if a flux comes into the word comes into the picture, means slag, 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 that also will come. If flux comes, slag compulsory will come, right? Okay, SLAG, FLUX flux, SLAG, slag. So this is the slag removed area. This is the slag which is prevailing over there. Okay, we will ask why you want to remove the slag. If you are not removing the slag, it will be act as a point to create a crack.
Not proper welding.
No, it's not a proper welding, or it's not a quality welding. Okay, it's like, see, if somebody want to see our hand, okay, if you are wearing gloves, if you can see our hand properly, the same way. Okay, this slag, it acts at a point for creating a crack, or this impurities will go inside, some mess will happen now. So the slag should be removed. So this slag happens, see, this slag should be removed by a process known as chipping. In our WP lab we will do chipping, right? After chipping we will go and wash the, we will pull down the weld area. See, if anybody has seen without doing chipping, if you are going to wash the weld area, what happens that we can't remove the slag. So that becomes an impurity, that is an improper welding, right? So the main advantage is that main advantage of this SMAW, this shielded metallurgic welding, or otherwise it is known as manual metallurgic welding. Manual, because it is you can do it completely manual. Okay, fitting of electrode, welding it, chipping and washing it is completely manual. It's always